Okay, today we're looking at solving logarithmic equations. So similar to solving exponential equations, there are similar things we do between the two. And there are probably three different types, just like there were three different types with exponential. What were our three different types when we were dealing with solving exponential equations? We got two exponential and we get the same base. That's one.
Where the base process was?
Say it again.
The six-step process.
Alright, so I've got two exponentials and I can't get the same base and I have to do the natural log. That's what you're talking about. And what's the last one?
One exponential.
And there's one exponential. Okay, so similar, you'll see similar things today with the logarithmic equations as well. So my first problem, I've got 14 plus 20, natural log of 7x equals 54. So thoughts on what we need to do to be able to solve this logarithmic equation?
Get the logarithmic part by itself.
Get the logarithmic part by itself. So in this case, you're going to identify this one as something that just has one log. If it's just got one log, get that log by itself. Is what we want to do. So to do that, what do we do to get started?
Subtract 14.
Subtract 14, so I have 20, natural log of 7x equals 40. Then what? Divide by 20. So I get natural log of 7x equals 2. So I have now successfully got the logarithmic part by itself. And once we get the exponential or the log part by itself, what do we usually do? Change forms. And Hunter, what do we need to identify to be able to change forms? Base and? Base and the exponent. So if it's a natural log, what's my base? E. What's my exponent? 2. So that means it has to equal 7x. Then to get x by itself, what do I do? Divide by 7, but if we're dealing with exponentials or logs, I'd rather you do what? 1/7. And I've still got people not wanting to do the fraction for me. Okay, do the fraction, don't divide by it. Alright, so at this point I plug it in my calculator. So I'm going to do e squared, and then I'm going to divide by 7. And that gives me 1.055 equals x. Now when we're solving log equations, we have to check our answers. What do we need to make sure our answers don't do? I can't remember if I'm dealing with the log, the inside of the log cannot be negative. So I need to plug my answer back in and make sure it doesn't produce something that's negative. So if I plug 1.055 in there, I can see that it produces a positive, and since it produces a positive, we like that answer. Okay. If it did give me a negative, then I would cancel it out. And if that was my only answer, what would my answer be then? No solution. Good. All right, another one similar to that. I have 6 plus 2 log of 5x equals 18. 6 plus 2 times log of 5x equals 18.
Subtract 6.
So again, it's a situation where I have one log, so I want to get it by itself, so I subtract 6. Which gives me 12, and then what do I do?
Divide by 2.
Divide by 2, so I have log of 5x equals 6. So Blake, the log is now by itself, so what do I do?
Change form.
And what do I identify to make that happen?
You have to identify the base and
Base and the exponent, what's my base?
10.
10, and my exponent is? 6. Everybody understand why my base is 10?
Yes. It's understood.
It's understood. If there's nothing there, it's understood to be 10. So again, I got to get x by itself, so what do I want to do? Divide by 5, which means I want a 1/5. And so I punch that in my calculator. I'm going to do 10 to the 6th. And I'm going to take that answer and divide by 5. So that gives me 200,000. Kendrick, what do I need to make sure of with that answer?
What's the question?
What do I need to make sure of with that answer?
I have no idea.
Christian? Make sure if I plug that back in, it doesn't produce a negative in here, because I cannot have negatives inside. So if I plug that back in, it gives me a positive, so I'm happy with that answer. So that's our situation, that's our first type, and that situation is when I'm dealing with one logarithm. If I'm dealing with one logarithm, what do I do? Get it by itself and change form. Good. Next one. I didn't want to do that. Alright, I have log base 8 of x squared plus 11 equals log base 8 of 92. Log base 8 of x squared plus 11 equals log base 8 of 92. So this time I have two logs.
Set them equal to each other.
Yes.
What do you mean set them equal to each other?
X squared plus, plus 11 equals 92.
So set x squared plus 11 equal to 92. Explain that, Kaylee.
Log base 8 is equal to log base 8, so they cancel out.
Okay, so if I have a log equal to a log, the insides have to be equal. Just like if I have an exponential with a base equal to an exponential with the same base, what has to be true? The exponentials have to be the same. Same thing here. If I've got a log equal to a log, the insides have to be equal to each other. All right, what do you do next?
Subtract them.
Subtract 11. So I get x squared equals 1. Then what?
Square root.
Square root it, and don't forget plus or minus. So I get x equals plus or minus 9.
Plug it back in.
Plug it back in, make sure I don't get a negative, and I should be fine because anytime I plug something into this x, what's going to happen to it? It's going to be positive, plus 11 gives me positive, so that means we like both of our answers.
So what happens if it's doesn't like
That was cute.
you just get like a cube?
Then I wouldn't like the negative 9.
So you would just say
I would say my answer is just be positive 9. And we'll see one of those here in a second. Alright, log base 11 of 3x equals log base 11 of x plus 5 minus log base 11 of 2. Log base 11 of 3x minus log base 11 of x plus 5 minus log base 11 of 2.
Did you just take out the log?
Nope.
You gotta set the logs up into that fraction stuff.
Yeah.
There you go. Very good. On the right side, I need to condense these two. I need to turn those two logs into one log. So that would be log base 11 of x plus 5 over 2. Everybody see that?
Yeah.
Now that I have a log equal to a log, now what can I do?
Set them equal to
I can set the insides equal to each other. So I have 3x equals x plus 5 over 2. Multiplied by 2. 6x equals x plus 5.
Subtract x.
Subtract. I get 5x equals 5, which means x equals
1.
1. Do we like 1?
Yes.
Yes, we like 1. I get x equals 1. So natural log of x plus the natural log of x plus 7 equals the natural log of 18.
combine them into one.
Combine them into 1. How am I going to combine them on the left? What do I do to combine them? Multiply. So that makes it x squared plus 7x on the left and the natural log of 18 on the right.
Set them equal to each other.
Set the insides equal. Whenever I have a log equal to a log, set the insides equal. So I have x squared plus 7x. Move it over and factor. Good. And we haven't factored in a while, so I want somebody to read this for me.
Factors of 18 subtracted 7.
Factors of 18 subtracted to give me 7. What's that?
9 and 2.
9 and 2. Read it the second time.
Signs are different.
Signs are different.
Biggest one's positive.
Biggest one's positive. Good. So that means I get x equals negative 9 and 2. Can't do negative 9, but I do like 2. So that means negative 9 is no good. The only answer I like is 2. Cross it out. So if I have an equation that is made up of just logs, what do we do? Combine them to where I have one log on each side, and then once I have a one log on each side, then I set the insides equal. If the bases are the same, then you can't set them equal. What was your question?
So why was 9 bad?
Because if I stick negative 9 in here, it turns this into a negative number, and you're
So
not
you're
allowed
gonna stick it
to
back
have
into the original equation.
correct. Alright, here's another one. Log of x plus 6 equals log of 8x minus log of 3x plus 2.
Condense.
So condense. What do you want to do to condense? Divide. Log of x plus 6 equals log of 8x over 3x plus 2. Everybody agree with that? Now what, Gage?
You're gonna wanna see the logs equal each other, so you can set the insides equal.
Very good. X plus 6 equals 8x over 3x plus 2. AJ, what do you recommend next? If x plus 6 equals 8x over 3x plus 2. Subtract 6.
No.
Multiply both sides by 3x plus 2 is what I want to do. So 3x plus 2 over here, and 3x plus 2 over here. On this side, it cancels it out. Leaves me with 8x. What do I have to do on the left? Pull it out. Good. So that gives me 3x squared plus 18x plus 2x plus 12.
18x plus 2x plus 12.
Get everything on the same side and put my like terms together. So if I do that, I've got 20x minus 8. That gives me 3x squared minus 12x plus 12 equals 0.
Wouldn't it be plus 12x?
Plus 12x? Yep.
Alright. And now you can factor.
You can factor out 3.
I can factor out a 3, but I can do it better. I can do something better than factor it out. Bless you. I can divide by 3. Why can I divide by 3 versus factor it out? Right, but why can I divide by 3 instead of just factoring it out?
Because all of these are divisible by 3.
Right, but I'm still not getting what I want.
It's 0.
What'd you say?
It's 0.
You're close.
0, 0.
Because if it's an equation, I can divide by it. If it's not an equation, then I have to factor it out. So if this equals 0 wasn't over here on the right side, then I would have to factor it out and then factor it. But since it's equal to 0, I can divide everything by 3. So I get x squared plus 4x plus 4 equals 0. So factor, how's that factor?
X plus 2 and X
What is it? X plus 2, x plus 2. So that means I get x equals negative 2. We don't like it though. So my answer would be no solution.
No solution.
Now, if it did work, what could I say about negative 2? It has a multiplicity of 2, and if I were to do a number line, what's going on at negative 2 on both sides?
Move in the same direction.
Right, that's graphically, but on a number line, what's happening on both sides of negative 2?
They're positive.
They're both the same sign. I don't know if they're positive or negative, but I know they're both be the same sign. Alright, very good. Okay, so here's a new type. So far, I've just got one log. The second type was what? Multiple logarithms where everything is a log. And this one is, I've got multiple logs, but not everything's a log. So those are our 3 different types. So, any thoughts on what I do to log of x equals 1 minus log of x minus 3?
Well, would you
Could you add?
subtract that log or add that log to the other side?
Right, get the logs on the same side. That's what you want to do first. So log of x plus log of x minus 3.
Then you can condense.
Now what?
Just making
Could
one
condense the
log.
logs.
Combine the logs, very good. So since there's addition, that means I need to multiply, so that's x squared minus 3x. Equals 1. Plus 2. Now we're back to the situation that we dealt with on the first type of problem. So what do I do once I get to where I have a log equal to a number?
Base exponent.
Base and exponent change the form. So what's my base?
10.
10. What's my exponent? 1. So I get 10 equals x squared minus 3x. Nope, because not everything's divisible by 3.
Subtract 10 and factor.
Subtract 10 and then factor. So somebody read that for me. Factors of 10, subtract to get 3. 5 and 2, and it says signs are different. Biggest one is negative. So we like x equals 5 and negative 2. Do we like both of them? We don't like negative 2. We only like 5.
Yeah, we don't like
Okay, let's do one more of those, and then I've got one more example that's not a log, but it's something we need to do. Alright, so log base 9 of 9x minus 2 equals negative log base 9 of x.
Ooh.
So log base 9 of 9x minus 2 equals negative log base 9 of x. Add 2 and add the log over. So I'll have log base 9 of 9x plus log base 9 of x equals 2. Matthew?
Will you get a totally different answer if you put the 9x and you subtracted 9x and put it over there?
No.
Right.
So condense these two. It's just a lot easier to work with the positives.
Right, but I didn't know.
Yes, you get the same answer.
Okay.
So 9, if you handle it correctly. So 9x squared there equals 2. Base in the exponent. So my base is 9. What's my exponent? So that has to equal 9x squared.
So 9 squared equals 9x squared. X has to equal 1.
Divide by 9. What is 9 squared?
81.
So 81 divided by 9, I get 9 equals x squared, which means
Plus or minus 3.
x equals plus or minus 3. Do we like both of them? No, we only like positive.
Is that 9
Squared, that's a 2.
Okay,
okay, I see.
after that has log equals n squared.
Because this right here is 81, and then I divided by that 9, which gave me that.
Okay.
So that is all of our logarithmic examples we're going to do today. What was the first type of logarithmic problem? There's one log. The second type, multiple logs, and everything was a log. And the last type, multiple logs, and not everything's a log. So those are the 3 different types of logs we've got to solve. Did you have a question? Okay. And now there's one more exponential problem I want you guys to be able to do. Let's see if you guys can come up with it. I have e to the 2x minus 15, e to the x plus 56 equals 0. And we want to see if we can solve this. I don't want to do that.
Could you factor?
I do want to factor it. And it may be tough to see that this is factorable, but after we do it, hopefully you see it's not bad. So how do you think we want to factor this?
E.
Factors of 56, that add to give me 15, so what would that be? 8 and 7, and both of them are negative. The question is, what goes over there?
E.
E to the x goes over here. Okay, so the question is, how do I end up with e to the 2x if I've got an e to the x and an e to the x here? And you have to remember your exponent rules. If I have e to the x times e to the x, what is it we do with the exponents? You add them. So that ends up giving me e to the 2x. So that's where the e to the 2x comes from. Okay? So once I have it factored, then what do? Set them equal. So I set this equal and add it over. I get e to the x equals 8. This one gives me e to the x equals 7. Then what do I do to both of them? I'm not done yet because I haven't solved for x. I gotta get, I would do the natural log. Very good, Christian. So I get x equals the natural log of 8, and I get x equals the natural log of 7. And we can punch those in if we want. So natural log of 8 and natural log of 7. So this one is 2.079, and this one is 1.945. Those will be my 2 solutions. Okay, so keep an eye out whenever you're doing that type of problem that wants you to factor it and then solve it. All right, very good. Okay, so we're doing 12, 14, and then 20 to 26 even, 50 and 52, and then 60 to 66 even, and 70 to 74 even. Now, number 20, I want you to change number 20 for me. Because I don't like it. Let's see. Alright, on 20, I want you to change it to log base 2 of m to the 4th equals 8. So replace that 32 with an 8.